Dear students, I myself S.H. Chobe, working as assistant professor in electrical engineering department of SND College of Engineering and Research Center, Deola. In the last 2-3 lectures, we are seeing the breakdown in the gases. When we are seeing the breakdown in the gases, we have primarily studied what do you mean by the ionization, what is the reason we have to study the breakdown in different types of, just like in gases, liquid and solid. Right? So in this high voltage engineering, we are first unit is the breakdown in the gases. And up to now, we have seen what is the primary ionization. In the last video, we have seen what is the secondary ionization. So in this lecture, we will see time lags for the breakdown. And second one, electrical discharge. So the first question arises, what do you mean by time lags for the breakdown? The time lags in the breakdown, it means that suppose the voltage is applied, at the time of the when the voltage is applied, there the breakdown does not causes to start. It takes certain times. It is called as the lapse of the time. It means certain time is required for the ionization of the gases to take place. And when this total ionization is completed, then and only then breakdown in the gases occurs. And this is called as the statistical time lag. What is this called? Statistical time lag, that is given by T years. Now, the second time lag is going to be the formative time lag. There is a time lag here, time lag for the breakdown. There is a time lag between the application of a voltage sufficient to cause breakdown and the occurrence of the breakdown itself. It means voltage sufficient. What is the voltage sufficient? Sufficient voltage means the voltage that is above the breakdown voltage. If you are not going to apply the breakdown voltage greater than the breakdown voltage, there is no occurrence of the ionization and there is no breakdown in the gas. So voltage, when we are going to apply the voltage and the occurrence of the breakdown itself, it means there is certain time is required. And this lag time is known as a statistical time lag TS. The appearance of the electron is usually statistically distributed. After the breakdown, it means after the appearance of the electron, a time TM is required, TF is required to ionization process to develop fully to cause the breakdown of the gas. And this is known as the formative time lag. There are two time lag, statistical time lag and formative time lag. The statistical time lag means the voltage we have put up or we have applied sufficient to cause the breakdown. But just I have applied the voltage, it does not mean that occurrence will or the breakdown will occur at the same time. It will take certain time. That time is required and that time is called as the lapse time and that is known as a statistical time lag. Now next one, see the diagram. Here the diagram is given. Here see the diagram here. This is the statistical time lag and this is the formative time lag. This is called as the formative time lag and this is called as the statistical time lag. Here is given the V voltage and here is the breakdown voltage. If the voltage is greater than the breakdown voltage, then only the voltage collapses and then only the breakdown of the gases take place. It means always remember that if you are not going to give the voltage sufficient, that is means more than the breakdown voltage, there is no ionization take place. There is no ionization, there is no breakdown in the gases. That is going to be the depiction of the time lag. There are two time lags, statistical time lag and the formative time lag. We have seen this one in the time lag of that one. Here, breakdown with a step function voltage pulse. First one, statistical time, and second one is the formative time. And T is the total time. For breakdown to occur, the applied voltage V should be greater than static breakdown voltage VB as shown in the figure. Now the next one, there is going to be the discharge, electrical discharge. What is the electrical discharge? electrical discharge in the gases are of two types. What do we mean by electrical discharge? Electrical discharge is nothing but the passing of the current between the two electrodes is called as electrical discharge. When the current is going to actually pass through that, starting to flow, then at this time you can say that the electrical discharge occurs in the gas and now there are two types of the electrical discharge, non-sustaining discharge and self-sustaining discharge. What is the difference between the name non-sustaining discharge and self-sustaining discharge? In the non-sustaining discharge, there are external carriers that are required to keep or to bring the electrical discharge in the gases. If the external carriers are not put up or not given, there is no discharge of the gases. See here, the breakdown in the gases is the transition of non-sustaining discharge into sustaining discharge. Now next one, see here. At a voltage lower than the breakdown voltage, current in the gas is due to the presence of external ionizer. Just I have told external carriers are required. At a voltage lower than the breakdown voltage, the current in the gas is due to presence of external ionizer, which continuously produces electrons and ions in the inter-electrode space. Just I have told external carriers or external ionizers are required. In which case? In the case of non-self-sustaining discharge. In self-sustaining discharge, we will see what happens. But in non-sustaining electrical discharge, external carrier or external ionizer are required to cause the electrical discharge in the gases or to current to pass in the gases, that is called as the non-sustaining discharge. What happened in this case? If suppose that if you are going to be put out or you are going to be taken away the external ionizer or the external carrier, then what happened? The current immediately ceases to flow in the space. Current will not flow in the space. And ionization under the action of the applied electrical field ceases. It means there is no ionization, there is no breakdown. This process is non-sustaining. One, it means it cannot maintain itself only to the expenses of internal sources of the gases. And if only due to internal sources, they can't put up the electrical discharge in this case. They require certain external ionizer in the gases to put up the electrical discharge. So this is called as the non-sustaining electrical discharge. Now in the case of self-sustaining discharge, we have studied the primary ionization and the secondary ionization. We have seen the difference between the primary ionization and the secondary ionization. So this self-sustaining discharge occurs only due to secondary ionization processes. We have seen the different types of the secondary ionization processes. Just like to what we are seeing is secondary ionization processes that electron emission due to positive ion impact, electron emission due to photons, then electron emission due to metastable and neutral atoms, and then lastly we are also seeing the electron attachment process. These are the secondary ionization. So this self-sustaining discharge occurs due to all this type of the secondary ionization process. The secondary electrons are produced by the secondary ionization. Remember, in the last lecture, I have told you what do you mean by secondary electron, right? Can I repeat it? You know that suppose there is an anode and the cathode. Two electrodes are connected to the electrical supply. If supply is put on, then what will happen? The cathode will eject or emit the electrons. Then where will the electrons go? The electrons will go to anode. They will positive ion, negative electrons. So they will attract it toward the anode. So this is called. So secondary electrons, it means what happened? But actually, what should happen? The number of electrons that are reaching to the anode must be equal to the electrons that are emitted from the cathode. The electrons that are reaching to the anode must be equal to the electrons that are emitted from the cathode. They may be less, but they can't be more. But when they are more, then at this time, these electrons are called as the secondary electrons because they are not in the due to the ejection or emitting from the cathode. They are produced in a different way. So these electrons, which are more, as the electrons that are emitted from the cathode to reach the anode, these are called as the secondary electrons. And the ionization takes place due to this one, is secondary ionization. And the self-sustaining discharge occurs only when there is a secondary ionization. In this lecture, thank you everybody. In this lecture, we have seen what is the time lag, statistical time lag, and formative time lag. What should be the voltage condition? It means the voltage should be greater than the breakdown voltage, then only the voltage collapse occurs. And now in this case, we have also seen electrical discharge. Non-sustaining, it means in this non-sustaining electrical discharge, external ionizers are required. External ionizers are required to conducting or to start the electrical discharge in the gases. But in the case of self-sustaining, there is no requirement of any external ionizer. They are due to the internal sources of that gases. It means due to the secondary ionization of the gases. So this is going to be. Thank you everybody. In the next lecture, we will see the remaining portion of the breakdown in the gases. Thank you everybody.